Okay, this is kind of a debrief of the first 3 worksheets for light in case you were absent for any of the days in class when we did this. This is for you to watch to catch up. So we already did the thought experiment when we had the cannibal and the blind cannibal and we tried to describe light, and we had a hard time figuring out what exactly light was. So then we looked at how light behaved. And knowing that light behaves as a particle and a wave, we're going to take a look more at the particle model of light right now and see why it does certain things. So this is mainly if you missed what we did in class. This is going to catch you up on worksheet 1, worksheet 2, and worksheet 3. So first of all, a ray, and this is what you want to draw whenever we're dealing with light. A ray is just the path that light takes. It's always going to be a straight line, and you're going to use arrows to show the direction that light travels, which is always going to be away from the source. So if we have a light source here, so a little light bulb or sun, so this is the source. Light is always going to travel away from the source and presumably into an eye. So the path that this takes is just a straight line. Let's use a makeshift ruler. Away from the source, and your arrows are going to look like this. So they always go away from the source into, say, an eye. And you're going to see on the worksheets, this is what the eyes look like. So I just, for consistency, draw the eyes like this as well. If you have whatever kind of source it is, the light, unless it's a laser, the light's going to travel in all different directions. So you're going to have rays going in a whole bunch of different directions. So a ray is any of these. I just drew 4 rays. The arrows point away from the source, and they're always in a straight line. Okay, now don't get offended with these definitions, but the next thing we looked at were shadows. A shadow is just the absence of light, so therefore a partial shadow would be the partial absence of light. And the way shadows are formed is when you have a light source. So here's our light source, and then you have some kind of barrier. So if we're looking to see where a shadow would form, we want to draw several rays coming off the light source and hitting the corners of the barrier. So in other words, these 2 rays get past the barrier. Any of these rays do not. So my shadow that's formed is going to be in this whole area. This will all be a shadow. If you have another light source, so this is all a total shadow. If we have another light source, you know what, maybe let's try and do this in gray. Make this big. So this is all shaded. Total shadow. Now let's say I add another light source here. I want to draw the rays coming off of this. So we're going to have rays coming here. You always want to hit the corners. And then we'll have some that go directly into it. So whenever you're figuring out where shadows are, you always want to make sure that you're hitting the corners of whatever your barrier is. In this case, with the first light source, we could only hit these 2 corners. The second light source I added, we could only hit these 2 corners. That just happens to be the direction that it's traveling. So now this area is illuminated by this light source. So this is only now a partial shadow, whereas this would be a total shadow. And sometimes I like to show that by making the partial shadow like that, whereas I would do a total shadow like this, just to show the difference. So if you're indicating where a partial shadow is versus where a total shadow is, that's only going to happen if you have more than one light source. So multiple light sources means that you'll have partial shadows. Only one light source would be a complete total shadow for absence of light. Okay. Now we're looking at pinhole cameras. Those came next. And what happens with a pinhole camera is you have a small hole, light's going to travel through that, and then it's going to form a reproduction on the screen. So the ones that we had in class, they were very simple. They were paper towel roll tubes, and then I put wax paper that acted as the screen, and then I had a piece of foil where I poked it with a pin for the pinhole. And what happens with pinhole cameras, so you've got the screen with a little tiny, the camera itself with a little tiny hole, and this is the screen. So screen, and this is the pinhole. I'm not going to do that because I need this space. And then you have a light source. And the light source I used was a light bulb that had an up arrow and a down arrow. The up arrow was black, the down arrow was white. And so what happened, and let me make this screen kind of three-dimensional. So this is the screen. So what happens whenever you're drawing diagrams for pinhole cameras, you're going to go from the top to the bottom, and you're going to travel through the pinhole and onto the screen. So you definitely need rulers for these. So we're going from the top of the source through the pinhole. As you can see, I'm not using a very good ruler right now. And then you're going to go from the bottom of the source through the through the pinhole and onto the screen. So what's happening when you get to the screen is an upside down image, because your rays from the top are now on the bottom, your rays from the bottom are now on the top, and it's also going to be inverted. I can't really show this three-dimensionally, but the same thing's happening right to left. So the upside down white arrow, which was on the right, is now going to be a right side up black arrow, and my right side up black arrow, which was on the left, is now going to be an upside down black arrow on the right. So pinhole cameras, what you need to know about those is how they work, how they reverse the image, both invert and reverse, so up, down, and left, right, and why that happens. And it's because light travels in a straight line. One other thing about pinholes, if I were to move the screen farther away, then your image would be less clear. So it would be a little bit blurrier, a little bit dimmer, and it would be much bigger. If I move the screen closer, you can see the crisscross happens closer, so the image would be smaller and sharper. And then the last thing that you might have missed would be intensity. This is just how much light hits an area. So think of a square area, how bright a light is. So intensity, or think in terms of brightness. How many particles or photons are hitting a certain area. The brighter it is, the more concentrated, and it's an inverse square relationship. So really what you need to know about intensity is proportional to 1 over the distance squared. So the farther something is, it has more area, but it's dimmer. And closer is the complete opposite. So the closer something has less area, has less area, and it's brighter. And you'll also notice that farther is blurry, closer is sharp. And a very popular analogy for the intensity is toast and butter gun. So say we have a piece of toast, and you have a butter gun. And this is just something that a chef may have invented. Say they want to butter a whole bunch of toast at the same time, so they invent a butter gun. And what that butter gun does, it sprays butter all over the toast. So if the toast is a certain distance away, it's gonna get all this butter. And let's just call this distance D. Now if we go twice as far away, so if this is 2D, I'm going to be able to fit, if I'm following this line, make my toast brown. Four pieces of toast. But there's going to be less butter. So we're covering a wider area, getting more toast buttered, but it's less than when it was close. And this is showing the inverse square relationship. So twice as far, you have 4 times as much covered, but your intensity is 1/4 what it was. If I went 3 times as far, we would have 9 pieces of toast. So now the light spread out over 9 times as many area, but each toast only has 1/9 of the butter. So think of intensity like a toast and butter gun. The closer it is, the less area, but the more butter, and it's an inverse square, so the farther away it gets, the less butter, but the more area covered. So those are what you missed in case you weren't here in class for any of those. That's it, and then we're gonna get into lenses. So this is all you need to know. If you didn't already do worksheets 1 through 3, those should be done, and then we're gonna start with refraction.